So switch back then to the DExplore perspective and open the UKCH 115, but now the Nexus one, which should have the same data as that file, DAT, but this is encoded differently in a Nexus file. And the benefit is, I think, that the Nexus file allows data compression, so it can hold more data, allows saving multiple data sets, and so it's a more effective means of storing data. And the good thing is that we can use it directly with Python to do some processing. So that's what we are going to do next. So the instructions here say open it and see show the data set plot visible, and then switch to the Python perspective. So let's go and explore a little bit the data in the DExplore's perspective. So we can close line trace because we already used it. And we are now wanting to open this, which is the UKCH, the Nexus data. And we have several entries in this data, but we are especially concerned about entry 1. And we are looking for the data that we can plot. The Nexus file has several groups. The default group for data is entry 1, and under entry 1 you have different data items like identifier, program name, and so on, which give you some information about where this data comes from, when was it scanned, and things like that. But now, for this exercise, we are interested in this group, which is counter timer, that has the energy, I0, IREF, IT, the logarithm of I0 IT, and the logarithm of the reference. So this is the data that we are going to try to plot using Python. And it's important to see this structure and understand the structure of the Nexus file. The next thing is it tells us to go to the Python perspective and create a new file. So this is what the tutorial says, that go to the Python perspective, create a new file, go into File, New File, select the folder where you want, which is data source, and use this name. So I'm just going to copy this name and use it in the Python perspective. So I'm on the Python perspective. This is my view because I have this file open. I don't have to keep it open because in the exercise, Python is going to open it again. So it's okay if you close it. So file, new file, data source. That's where we want to create the new file. And this is the name, readnexus.py, and finish. And now the next thing we are going to do is to fill in the parts of the script. So like your blank canvas, and we are going to start filling in the import modules, the functions, and the script body. First, the modules that we need. I took this example from this address because the Nexus format is used by many different installations, not only ISIS and Diamond, but around the world. Nexus format is a joint effort to provide this format for scientific data. And it's based on another data format, which is H5Py. These are modules that we are going to be needing for managing this type of files. So if we use copy and paste this into the Python file, the read Nexus file, we use copy and paste. So those are the 3 libraries that we need. Next, we need to create a function. And this is a function that I created to get the data from the Nexus file, not the data itself, but the paths to the data, because we need these paths to access the data items inside the Nexus file. So if you use copy and then paste this part, then you have the second piece of this puzzle, which is the function that gets the data. The next thing we need is some variables to hold the information in memory while we are working with it. So these variables are places in memory that are used to keep some information. So we need the directory, the name of the Nexus file, the file, a variable to hold them together, and a data group. So remember that I told you that it's important, it was important to explore the file and know the name of the group that we are going to be using to get the data from. So if we copy and paste this into the readnexus.py file, so directory uses OS environment and user profile. This is for the Windows user, because I assume we are all trying to do this on a Windows computer. If you are using a Mac or a Linux computer, there is a different command that's needed here, but for us, we need this one. And then we add workspace, which is the default place where these workspaces are stored. Then data, which is this data group, and examples that tells me to go to this other folder. So that's just getting where the file is, and then the name of the Nexus file, which is the same as this one, MOKH 115. It gets them together into a single file, and then we need the data group. So that's the variables we need. The last part of the script is the body. And this is a very long body. It's complex because we are getting many things done. So we are opening the file, we're extracting the structure, we're extracting the data, and then we are plotting the data. So these things happen in the script body. Again, we can use copy and paste below. That gives us a full script that can now do what we said. If you run it, then you will see the results. So the first thing it says is, do you want to save your changes? Yes. And it starts running. And immediately you see the first plot. So it got the data. It got the energy points, the IO0 points, the IREF, so on. And it's going to plot each one against energy. So this is the first plot. That's I0, that's IREF, and so on. You can see them. This is a constant, and this is the the mu or ln0 I0 IT, which is something that the XAS processing uses a lot, and this is a reference value. This shows using the Nexus file without DOM. Up to this point, we are using OS, H5Py, and matplotlib, which is a plotting library. And that's all we are using for opening the file, getting the data, and showing the data. The benefit of using this, well, for instance, you can make it larger. You can start zooming on these diagrams. You can zoom to different regions. You can use this backward and forward to see the regions as they are selected. You can reset, and you can also save the plots. For instance, if you would like to use them in a publication or something, you can just click on save.
Just one small question, Abraham, about the figure itself. So if we want to export the figure, so how we do it? So we export it as an image, or we can export the XY data? For instance,
at the moment,
the figure, or when we play with the range that we want to show.
you can do it, but you can do it in different ways. You can use your use the commands. These buttons in the lower part of the figure control the what we do with it. So this is for zooming in. Yeah, this is for dragging and dropping when we have a zoom. And this is for moving between the different parts that we did now. And this is resetting. And this saves the figure. And that, for instance, in here is asking me, where do I want to save it? And it's saving it as a PNG, portable network graphics, or JPG, or whatever we want. So for instance, if I say, I don't remember what was the lref dot PNG. I think you can leave it without the extension and save it. I'm saving. I will save it to the desktop. Save, and that's it. You have the image, not the data, not the data, but you can save the data from within the Python code. I can show you later how to create a CSV file from this.
Okay.
Okay.
Okay. Thank you.
That's it. Yes.